evening, but no one has now. Okay, let me wait for a few minutes, then we can. So till now, no one has joined. Let me start discussion. Then eventually, if anybody joins, then he or she can follow. Okay. So let me start. This is visible. Yeah. Today, I don't know whether recording is going on not fine. I don't know because no one has joined till now, but screen recording is going on. Yes. Okay, so uh, you can follow. I will record the entire lecture and I will upload in the YouTube and I will share the link in the spreadsheet as usual and you can follow from there as well. Okay. So today we'll discuss thermo chemistry basically and also we'll discuss the concept of fugacity. These things we plan to discuss. Okay. So let me start with discussion of thermochemistry first. Then we'll discuss the fugacity part. So let me start with the question. Okay. The Molar heat. I just started.
Okay.
First, we'll discuss the thermochemistry and then the fugacity part. Today, we'll discuss. That's our today's plan. The molar heat of combustion of C2H6, which is in gaseous form, carbon, which is graphite, and hydrogen gas are these values of heat of combustion is given. Okay, these values are 13.62 kilocalorie, 94.05 kilocalorie, and 68.32 kilocalorie, respectively. Then we have to calculate the standard heat of formation of C2H2 gas. Okay, so this is our question. So, do you know these things? What is the heat of combustion, heat of formation, this definition of this?
Yes, a little bit.
Okay. Then here first we have to understand what is the heat of combustion means. Okay. Heat of combustion means first let me define it.
Energy released when it is combusted in air.
Yes, but totally. Okay.
Yes.
Means you have to combust when in the air, open air, you are considering the 1 mole of that species. That is important. Means
Complete 1 molar of the species.
hmm, just let me write heat of combustion that is defined as, let's say you have a species which is X, any X species in gaseous form. When you burn that species in air, then it will form oxide. You have to consider 1 mole of that species. Then the heat for this change, as you know, while burning, heat will release, obviously. Okay. And that heat obviously will be equals to the change of the enthalpy. Delta H, this you know. So delta H will be H product minus H reactant in general. So this delta H is called heat of combustion. Okay. Because here obviously delta H will be equals to the Q heat. So from here you can write this is the definition of heat of combustion. This H is delta H is heat of,
Why delta H is equal to the Q?
you say it, why delta H should be equal to the Q. What is the definition of DH?
No, sorry, I got it.
Of, because these all reactions are at constant pressure.
Yes, constant pressure.
That's why. So heat of combustion. Okay. So this is just written as delta H. No suffix. Okay, just delta H. Heat of combustion. Just I'm giving example, then it will be more clear. Let me give me some example. Let's say if you ask the heat of combustion for hydrogen gas, hydrogen, then it will be H2 gas plus O2, then it will form the oxide which is water, vapor. But you have to balance the equation. You can't change this, so you can only change. You have option to change
2H2
the,
plus
no, not to H2 plus half O2. That's why I'm saying you can't do it. You can't do it.
Yes, this is a standard equation I read.
This is the standard equation you read, but for this reaction, the change in enthalpy delta H that will not be equals to the delta H combustion, you say. That is not. Here you have to be careful. The definition is you have to consider this as one, and accordingly we have to balance the equation. Then the heat will be the change in enthalpy will signify the heat of combustion. Okay, if you multiplied with 2 previously, then the heat will be the 2 times of heat of combustion. Okay, just these things we
Okay.
have to clear. If here is n, then the heat delta H, this is actually n times delta H heat of combustion, not the heat of combustion. That you have to uh, keep in mind. So this is the
Which one I have to keep one?
this
First component.
because this is the heat of combustion of H2, na? Oxygen is constant. This is signifies you are burning that species in air. That's why it is oxygen.
Yes.
This part is common for each and every species. But you are changing this species and you are measuring the change in enthalpy, and that correspond to the heat of combustion of that particular species. So you have to keep unimolar of that particular species for which you are interested to calculate the heat of combustion. Okay.
Okay.
So and what is the value of this? This delta H is minus 6840 kilocalorie. So whether it is exothermic or endothermic reaction.
Exothermic.
Why?
Energy is released.
Energy is released. Because delta H, how you can remember, delta H always HP minus HR, and you know this reaction. So that means this is HR and this is HP. You can think like that, and this change is actually the del H. So delta H is negative means this is the exothermic reaction. Okay. Okay. And also one more example, you can see sulfur. Here you don't need to balance because it's already balanced reaction. So and this is minus 71 kilocalorie. So this is the heat of combustion. Okay. So and one more thing you have to understand, that is heat of formation. Then you can solve this type of question. Okay. And this question asks, I will say in gate or net, even in jam. In jam, I'm not sure whether you will get always in every year. That is, I'm not sure. But in gate or net, you will always get. In gate, there is a question and net also. And this type of question are not very difficult because all informations are provided in the question. You have to just manipulate the question according to according to the question what is asked in the question, and then you can get. Just you have to remind these definitions. Other everything will be given in the question.
Net net exam is conducted for physical chemistry specialization or all chemistry syllabus.
Net.
Yes.
No, net is for all. In case of net, there are three sections. Section A, section B, section C. In a single question paper, you will have three questions, three part, three section. This A is for general aptitude. Okay. In general aptitude, you will have 20 questions. You have to answer 15 questions. And each question is for 2 marks. So you will have the 30 marks from part A. Okay. In part B, you will have 40 questions. You have to answer 35 questions. And each question will have the 2 marks. So it will be 70. This is for from chemistry. This is also from chemistry.
I have
Okay.
no choice for specialization.
No, let me complete. Then in C, you will have 60 question. You have to answer 25 question, and it will be each question will be 4 marks. So it will be 100. And for each question, there will be 25% negative marking for each question. So that is constant. But here you can fix because from part C, you see this is the most important part. Part C. Among these 60, 20 from inorganic, 20 from organic, 20 from physical. Okay, and you have to answer total 25 questions. So you can see there is the specialization part appears.
Yes,
Okay, so basically that's why lots of people prepares to, but that is not correct thing, because it may happen in 1 year organic become easier, in another year physical become easier. That always keep changing. So it's better to prepare all three parts. Obviously you will have specialization in one part, obviously, that is sure. But you have to be you have to also be serious for other parts as well. Then you can do 25 questions, because now it's totally computer based. You can't make answer more than 25 even. So you have to answer 25 questions. So that's why you have to choose. Here also, among 40 question, 13, 13, 13, 13, 13, like this discrimination are there. So it is totally equipartition is there. But you have to uh, keep in mind what part you have to target. Okay. So that's it. But according to me, you should avoid organic part in this part C. Because in organic, if you attend 10 questions, 60% question will correct, 40% will be wrong. If you have total preparation, then also, I can say the
that is
success
very weak for me.
so success rate is very poor. No, that is weak for you, that's okay. But who has organic specialization and who has studied organic very well from Claydon, Caruthers, all other renowned book, for them also after attending a 10 question, I can bet 6 will correct. 6 to 7 will correct. But in case of physical, I say the success rate is very high, because you can check the answer now. You have a question, you have a problem, you are getting some answer, and you will see whether that is matching with the provided options or not. And according to that options, you can there is a checkpoint, so you can check whether you are correct or not. So if you attempt 10 question, 9 will be correct, I say, if there is no silly mistake. And inorganic always lies in
Yes.
between organic and physical. That is always, because in inorganic part there is these parts are there, no block elements, C, D, F, not C, sorry, S, P, D, F. These block elements are there. So in from block elements, these type of questions are very tricky and totally memory based. There you don't know, then you can't answer. There are some part. Although in inorganic organometallics, coordination, from these parts, lots of question asks. This part is also good. You should prepare that part also. So, but you have to. That's why getting CSI and NET, CSI and NET is totally a different thing, because you have two types of preparation are there. First is you have to prepare all topics. That's great, but you have to specially prepare for the exam pattern. That is a totally mind game. You have to literally plan for it. Which part you have to target, which types of question you have to leave, because you see you have limited time, 3 hours, and you have among in between that time you have to study all 60 question, and from that 60 question you have to pick 25 only. You have to leave 35 question. You should not answer those questions. So that part is very very tricky. So question selection is very very important. But in gate, that difficulty is not there, because in gate you have 100 question, you have to answer 100. All questions you have to answer. There is no option selection, nothing is there. So that part is for that's why qualifying gate is easier, because you just studied and you will. But in NET, your presence of mind, your civic sense, uh, common sense, this will play a very important role. Okay. And jam also. Jam and gate are equivalent to, I say, because this jam and gate actually conducted by IIT this institute. So these questions are more or less similar kind of questions. And now gate can also be appeared by the BSc students, I think. Yes, BSc or MSc first year students. So that's why the level of that question also be somehow downgraded.
It is from BSc syllabus.
No, actually MSc syllabus, but few questions are from there. Few questions from BSc. But NET is, I'm not saying in NET all questions are difficult, but you have to pick that easy question. Among 60 questions, there will be 10 to 15 questions very easy from all three disciplines. But you have to pick that. That is quite difficult. You are picking that easy question. Okay. So now heat of formation. Okay, so here also, as the name suggests, this is the heat of formation. So you have to formulate something from its key ingredients. Okay. So what is the definition of heat of formation? So just I'm writing the definition for, just let me write it. The enthalpy change associated with the formation of 1 mole of a compound from its element under standard condition. So what does it mean? Let's say you have to calculate the heat of formation for any species X. So you have to formulate 1 mole of that species from its uh, elements. Let's say if it is A and B, then from A and B you have to prepare that 1 mole of X. And for that process, the change in enthalpy, that is H product minus H reactant, that is essentially the del H F heat of formation. Okay, so is it clear?
Yes.
Okay, so let me have some example. Heat of formation of methane. So you have to prepare methane, 1 mole of methane from carbon and hydrogen. So what will be here?
2H2.
2H2. So for that, the change in enthalpy is actually the heat of formation of methane. Just another example. Uh, if I ask carbon dioxide, then it will be carbon.
Carbon plus oxygen.
Hmm. What will be the values for this reaction? This is 96.96 kilocalorie, and for this reaction it is 18.50 kilocalorie. Okay, so after knowing this definition, now you can do what is given heat of molar heat. You see, this is molar heat of already molar is mentioned. If this is not mentioned also, then you have to also consider 1 mole. By definition, it is 1 mole.
Okay.
So C2H6, carbon and hydrogen. So what will be that reaction then? So first C2H6, you have to burn C2H6 in oxygen, then it will produce CO2 plus H2. And you have to balance. This is
Yes.
obviously in gas phase, that is also written in the question. So if you balance it, then it will be 2 and it will be 3.
3/2 O2.
No, it should be
7/2.
5 by 2. 5 by 2 or 7 by 2? Okay,
7/2.
7 by 2. I think this is a print typo here. Yes, it's 2 not 6. Okay, sorry. Hmm. Now it will be
5/2.
5 by 2. 5 by 2.
Yes.
Hmm. Okay, 5 by 2. So what will be the delta H for this reaction that is given in the question? Uh, 31.62 kilocalorie. Okay, so minus all in kilocalorie per mole, kilocalorie per mole. Second reaction is our carbon, which is in graphite form. So carbon that is in graphite form, we have to burn that in oxygen and it will produce obviously CO2. And del H for this reaction is, let me name this reaction A, B, C. This is delta H A, delta H B. It is 94.05, right?
Yes.
Mm. And third reaction is that is also for H2.
H2 plus half O2 to H2O.
Just H2. Okay. So now from these three reaction, you have to formulate the reaction which correspond to the heat of formation of C2H2. So what is the heat of formation for C2H2? Which reaction will suggest? You have to formulate 1 mole of C2H2 from carbon and hydrogen. So you have to consider this reaction, right?
Yes.
So how you can make this final reaction from the A, B and C?
First reaction plus 2 into second reaction plus third reaction.
First reaction will be negative.
Yes, it will be in reverse direction.
Hmm. Reverse reaction. So it will be 2B, not 2B plus C minus A.
Minus A.
So then it will be 2B means 2 carbon plus 2O2 plus H2 plus O2, and here it will be 2 CO2 plus H2, and you have to minus A, that means you have to consider reverse reaction. So here it will be 2 CO2
Plus H2O.
plus H2O, and here it will be
C2H2 plus 5 by
C2H2,
2O2.
exactly, C2H2 plus 5 by 2O2. Therefore it will be, so you see this cancels, this cancels, right? It will be
Yes.
there. So you can finally write from here 2C, how many O2? 3.
O2.
3 O2, 3, and here it is 5 by 2.
Half O2.
Now O2 should not be there, so there is some mistake. Here you see how many O2 is there here. Is that balanced?
Yes.
Then why it is not matching? One O2 is missing, I think, right?
Yes.
Oh, here it is half O2.
Yes, it's half O2.
Hmm. Now
It's
it is
matched.
matching. Hmm. So it is just okay. So obviously now we can write. So delta H formation of C2H2, just you can write like this, C2H2, that will be 2 times B. B is delta HB, so 2 into delta HB plus delta HC minus delta HA. These data are already given to you, so just put it. So it is 2 times minus 94.05 in all kilocalorie per mole. It is minus 68.32, and this is minus 31.62, all are kilocalorie per mole. Just calculate it.
Minus 224.8.
So it is okay. 1 minute. It is actually 10. I missed. Sorry. Now calculate.
Minus 54.2 kilocalorie per mole.
Minus is there.
Sorry, 54.2.
54.2 kilocalorie. Okay.
Yes.
So this is the procedure. You see, this is very straightforward reaction. Just you have to calculate it. Then you can easily can determine the.
If not match, then what will I do?
Then you have to look at where is the mistake.
It will
You see
surely
that.
match.
Uh-huh. It is just a normal algebra. Okay. Next question,
This is same for heat of combustion also.
which is
This type of mathematical
ha ha
problem.
ha ha ha. Ha. Same. Heat of combustion, heat of formation. I'll do all. I'll try to solve similar kind of problem. Here also I'll solve one more problem from this heat of formation. Then we'll solve it different problems. So let me do it. This problem you should try first. The same kind of problem. Heat of combustion of ammonia and H2 are 9.66. Sorry, it's 6. What is written? 66 and 68.9 kilocalorie respectively. Per mole is not written because you see this is for all for 1 mole of gas. Okay. The heat of formation of, calculate the heat of formation of ammonia. Now I am giving the options as well. First is 94.29 kilocalorie. Now just do it. It is equal. Just try
I
it.
think I think heat of combustion of nitrogen and hydrogen should given
Why?
N2 plus 3H2 to 2NH3 the reaction of ammonia formation.
No. Just right. Every data is sufficient. Data is sufficient.
Okay.
tight, then otherwise I will do.
Okay.
Let me start as well.
Please show the upper screen.
Mm-hmm. Okay, you try it better. Follow the same procedure that is discussed in the last question. Same procedure will be followed. First, you see the heat of combustion for ammonia and hydrogen is given. So, heat of combustion means you have to burn ammonia in oxygen. So, it will give you,
Nitrogen plus water.
yes. So, how you can balance it?
3 by 4 O2, half N2 and 3 by 2 H2O.
Yes, correct. And this is given, this del H for this reaction A, that is given 9.06. Okay, minus
Yes.
9.06. Why minus?
Heat of formation, sorry, combustion,
Heat
energy
of
released.
combustion, energy will be released. That's why. That will be not written here. That you have to understand. Because it is already mentioned this is heat of combustion, means the released heat. That's why. So now, for the next reaction, this is reaction A, and given for it is hydrogen. Hydrogen already we have discussed, it will water, and for it is this one. So from here you have to formulate the reaction which correspond to heat of formation of ammonia. So heat of formation of ammonia means you have to prepare 1 mole of ammonia, and from where N2 and H2. So it is
Half
half.
N2 plus 3 by 2 H2.
Just you have to make it. How you can do it?
First reaction in reverse and second reaction multiplied by 3 by 2.
That's it. Then it will be 3 by 2 H2 plus 3 by 4 O2 plus up into 3 by 2 H2O. From here it will be 3 by 2 H2O. That's it. So H2 gone away. Hmm. It will be up into plus 3 by 2 H2 ammonia. So how we can write? So delta H formation for ammonia, that will be 3 by 2 delta H B minus delta H of A. So what is the value? 3 by 2 into minus 68.9 minus plus, it will be 99.06 kilocalorie. So what will be the answer?
Minus 94 point.
Oh, sorry.
Option B, I think.
Option B.
Please show the option.
1 minute. How it can be? 91.8, I think, right?
Yes.
No. Total. What? 94.29 kilocalories. So it is, yes. So it is option B. So whether it is exothermic or endothermic, which kind of reaction is this?
Exothermic.
Exothermic reaction, yes. Just let me turn off. Sort of. Ja. Okay. So this is question number 2. So this kind of question, I think you can do it now. So now next, this is quite different type of question. Okay. Let me write it first. Quite long question. It will take time to write. 1 mole of naphthalene was burnt in oxygen at constant volume to give carbon dioxide and liquid water. Obviously at 25 degrees centigrade. Heat evolved was found to be this amount of heat the enthalpy of reaction at constant pressure will be. Okay, this is the question. How you can approach?
Please tell the formula of naphthalene.
Oh,
That I know, but the formula.
from here you have to calculate the formula. Just try to calculate.
I am getting C10H8.
C10.
Yes.
How? Are you sure?
Sorry,
C10H8?
C8H8.
C8H8. H is clearly visible. How many H are there?
8.
8. And carbon?
8.
8. How? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes, this is I was saying.
So I said it is wrong. C10H8. You said C10H10. Okay, whatever. So C10H8. So this is the formula of naphthalene. So now 1 mole of naphthalene was burned. That means the combustion, heat of combustion. So C10H8 is burnt in oxygen. So it will obviously give CO2 plus H2O. Now balance it. 10.
4O2,
So here it will
7O2.
be
No,
12,
12O2.
12O2. And
How
this is
to
the,
do this reaction?
how to?
Do this reaction at first.
I don't understand. At first means
At first, I write the C10H8 plus O2. Then what thing I will write? The number of CO2.
you have to balance the reaction just like this. You know this will form. Then you have to just balance. That's it.
At first, 10 CO2 will form.
No, just you write CO2 plus H2O. You know CO2 plus H2 will be formed, oxide will be formed always. So just
Yes.
write CO2 plus H2O and then you will just balance it. You have to balance this. That's it. Here it is explicitly mentioned. It is not always be mentioned in the question, but here in the question it is explicitly mentioned that water and CO2 gas is yeah, formed, right?
Yes.
So just you have to balance it. Okay. So this reaction you can do in your home as well. Just you can burn it. Okay. But you have what is the important point here? You have to keep it one. You while doing balancing, you can't change it. It should be one. Okay.
Yes.
And for this reaction, the heat combustion is this minus 5.1388 kilojoule. Okay. Now you have to calculate the enthalpy of reaction at constant pressure. Okay. This you have to calculate. Means enthalpy change, obviously, not enthalpy. This would be means enthalpy change, not enthalpy. Okay. This enthalpy change. So this reaction was performed at constant volume. Okay. So, okay, this is very interesting question. So, for this, just this is a purely thermodynamical question. Just see, this question, this is the heat, but this is constant volume heat, and you have to calculate the enthalpy change for the reaction at constant pressure. Do you get it?
Yes.
So this is essentially this UV is not the delta H,
Yes.
it is delta U,
Yes.
correct? So it is actually delta U. That's why you see here is not written the enthalpy change, here just written the heat evolve.
Yes.
So, and you have to calculate the QP, and QP, you know, that is delta
Delta
H.
E.
That is delta H. So delta H equals to del U plus
P delta V.
P delta V. Get, so how you can do it? So you can write it QP, QV, and delta V. Delta V is actually delta N into RT by P. So P delta V is this.
Yes.
So this is just G, delta N G. This is for gas only. So you can write it. So what is the delta Ng? Because in question given,
-2.
it is liquid. This is gas. This is gas. This is solid. So obviously it is 10 minus 12. So it is minus 2. So now you just calculate, it is minus 5138.8 in joule, obviously, and minus 2 RT. R is
1
8
point
point, no, no, in joule it is. So it is 8.314,
8.314.
and T is 298. Calculate.
298.
So what will be the answer?
Minus 10.093 kilojoule.
10 point. How?
I am getting minus 10,093 joule.
Why?
298 into
Oh,
2,
sorry,
that's a
sorry,
huge
sorry,
number.
sorry, sorry. Hmm. Now you do it. This is in kilojoule. Okay. Is it clear why this should be considered like this? This is in kilojoule.
Yes. Minus 5143.75 kilojoule. This is very conceptual question.
Hmm. That is important. Just you can write it as delta H. This is here, it is delta U. So whether the experiment is performing under a constant pressure situation or under a constant volume situation, according to that you have to decide that is equal to delta U or delta H. Okay. So the next question, so number 4. Enthalpy of combustion. So thermochemistry is basically the application of thermodynamics in a chemical reaction, like that. Kilojoule per mole. Right?
Please wait.
Hmm. You have 5 minutes to do. I think that is sufficient.
One 69.1 kilojoule.
160. Let me check with 169.1.
Yes,
No, but answer is not matching. Let me do it. First, I'm writing your answer. Just say it again. One
69.1.
kilojoule. Let me do. What are the given data? Enthalpy of combustion of glucose. Glucose. What is the formula of glucose?
C6H12O6
Hmm. So heat of combustion. This is
plus
yep.
6O2, 6CO2 plus 6H2O.
Hmm. So this is our delta H. Let's say A. That is given 2816 kilojoule. Okay. And the delta H of formation of glucose we have to calculate. This is we have to calculate. And these data are also given CO2 and H2O. So CO2, it will be from carbon and
C
oxygen.
plus O2,
Hmm. Hydrogen, oxygen. Just
H2 plus
balance
half
it.
O2.
Exactly. So it is, let's say I'm writing delta H B, and that is given as
Minus
390.5
393.
kilojoule. and it is 285.9 kilojoule, right?
Yes.
From here, you have to make the reaction which correspond to the heat of formation of glucose. So from carbon,
C6 plus 6H2O.
no, not from H2O. You have to make it from the elements. Okay,
Okay.
not from H2O. You don't have to write the reaction. You have to make it from the elements. So this is the elements, na carbon, hydrogen, and oxygen. These are the raw elements. So then you can balance it. So it will be 6C,
6H2, 3O2.
6, oh sorry, 3O2. 3O2. Now how you can form this?
First
6
reaction in backward direction and second
backward
reaction multiplied by 6.
6B plus 6C minus A.
A.
I think it's the correct. Just do it. So then 6B means 6C plus 6C plus 6O2. Here it will be 6 CO2. It will be 6 H2O, but it is 6 H2 plus 3O2. This backward means here it will be 6 H12O6, and here it will be plus 6 O2. Here it will be 6 CO2 plus 6 H2O. So it is forming, right?
Yes.
Okay. So what will be the heat of formation now? You can calculate the heat of formation for C6 H12O6, and that will be essentially 6 times B and C. So B and C means delta H B plus delta H C minus delta H of A. So it will be 6 times minus 393.5 to 85.9, and it will be now plus 6 this kilojoule. So what will be the answer?
Minus 1278.4.
Okay, that will be the answer. So that's why it was not matching. You consider this reaction wrong, right?
Yes, but the both are same thing.
Both are same thing, but while balancing it will be wrong. Correct? If you write it as
Yes.
as H2O, then from ABC, when you formulate this reaction from the reaction A, B, and C, then this will not be the same. This will different, and the numerical value will be different. That is the problem.
Yes.
So you have to very conscious about this. Okay. So this is question number 4. Okay. What is heat of formation of benzene from the following data? Assuming no resonance bond energies are there. So what are the data? data are C single bond C, sorry, 83 kilocalorie. This is the bond energy, okay? This is given and also given heat of atomization of carbon is 55.1. These data are given.
Please wait.
Okay. You know the heat of atomization?
When the compound is turned into atom, the energy released.
Okay, try.
One 174 kilocalorie.
What? Hello? Hello?
Yes,
Huh. What is the answer?
174 kilocalorie.
170 kilocalorie.
174.
174. Check it. Check it again.
At first, I am getting 1512, 1512 kilocalorie, then minus the heat of atomization.
Okay, let me check. So first, what you have to find out? Find out the heat of formation of benzene. So benzene means C6H6, right? And heat of formation means it is from carbon and hydrogen. Correct?
Yes,
We have to find it, this delta HF. And you have the data. So how you can find out this delta HF? It is eventually the H product minus H reactant. Correct? So you have to just know the value of HP and HR. Okay,
yes.
let us do. So now what is given? Given that heat of combustion of carbon and hydrogen. So that is C6H6. If you from this, for this reaction, the delta H will be, uh, you have to calculate the delta H. For carbon, it will be 6 into 170.9, and for hydrogen, it will be this. Calculate it.
1338.
And
And
we
for
have,
benzene, I got 1512.
let us check. Now this is if you burn it, and now what is the case? That is, these bond energies are given, right?
Yes,
So you have to calculate. Now this is the H reaction. Okay. Uh, for reactant, it's okay. And the bond energies you have to calculate. So what will be the bond energies? That is important. There are CC bond. There are okay. Now if you look at benzene, let me draw the benzene first. So this is benzene. So these are CH. So let me just. These are CH bonds. So six CH bonds are there. C single bond C. Three are there. These are three, and three double bonds are there. Correct. So this is our benzene. So if you calculate, then it will be bond energies. I'm saying the bond energies. This is given here. So these are bond energies means the when you just you have to formulate from this carbon carbon C single bond C. You have to break it. How many energy will be released? How much energy will be released? That is the bond energy.
I am getting 1512 for the total.
Okay, let me calculate. So it will be 3 times 83. So it is 3
Why?
times 383.
6
3
cc single bond and 3 cc double bond.
where is 6 single bond C?
At first, all bonds are single and then 3 are double.
It should be like that. When you are considering C double bond C, here both bonds are already counted. When you are considering this is a double bond, this is already you are considering both bonds, two bonds, not the second one specially. It is not that you are calculating the second bond energy additionally. It is total considering the both bonds. Okay.
Then I have made mistake here.
Now you calculate. So it will be 3 times 83. Obviously, minus sign will be there that we can add later. And it will be 140 and 352.1 kilocalories.
Hydrogen is 6.
Yes, 6. So it will be this.
981.6.
No, it is, sorry. It is 99. Sorry, it is 99. Sorry. Yeah, fine.
1263.
1263. Okay. So now you can calculate. Uh, so what will be the delta H formation? It will be minus, obviously, the minus sign I give.
Minus 75.
Minus, not minus, plus. Because that is in positive. Okay.
Heat of formation can be positive also.
Hmm. Obviously. Heat of combustion cannot be positive. Heat of formation can be positive.
If heat of formation is negative, then it is stable. It releases energy. And if it's positive, it is
You
unstable.
have to provide, no, you have to provide energy. There are many reactions which are endothermic. You have to give the energy. There are lots of reactions.
Okay.
Okay. So this type of question you, I think, 1 minute. Let me find one more this type of question because you did it wrong. So that's why. This one calorimeter will not be important. There is a portion of this thermochemistry where the um, working principle of bomb calorimeter has been discussed. That I am not doing discussing here because that is not important. I think. I have never seen any question from bomb calorimeter. You can ignore.
Is that machine useful in today's science?
Hmm. Hmm. Obviously, bomb
It is in
calorimeter
the IITs.
probably I don't. Hmm. I have never seen any. I have even not seen the NMR machine. Never. Not NMR, not XRD. I had nothing I have seen.
That is not needed for physical PhD.
In experimental, obviously, that is needed, but for theoretical, it is not needed. Never ever be needed. Okay. Okay. So it was question number 5. There are few questions like this that we can discuss in next class because today after doing this question, we will discuss the fugacity part. Okay. That is pending from lots of days. So there are 2 4 questions, 2 3 questions are there, but let me do it. This is the last part, last question. Then we can uh, s- move to the fugacity part. Okay. Mm, Probably the fugacity part will not be completed today, but majority will be there complete. What is the resonance energy in acetic acid? You have to calculate it from the following data. And what is given data? That is the bond energies for CH, CC, CO, CO, and OH. And the heat of atomization also given. The same type of question for carbon, oxygen, and hydrogen. What are the values? This is all in kilojoule. Just right, following the same procedure. What is the answer you are getting?
Minus 480.6 kilojoule.
No. Try, do it properly.
How to calculate the resonance energy?
Just you have to consider the two forms of acetic acid. Okay, that
Yes,
is
but both are same in two forms. No bond is changing.
no bond is changing means
It has equivalent resonance structure.
equivalent resonance structure. That's correct. But in one bond, you have to consider there is a resonance energy between these two bonds. You know how to calculate the resulting structure.
What it means?
You have to calculate. Hmm. Calculate the resonance energy. Hmm. Okay. You can calculate what is, let me draw the structure of acetic acid. This is like this CH3 COOH, correct? Is it correct?
Yes.
And another structure will be this. And these two structure are equivalent, right?
Yes. So no
And
bond is changing.
no bond is changing. But you have this. What is the heat of formation? So what is heat of formation?
For forming the pure acetic acid in
Of
standard
carbon,
condition
hydrogen, and oxygen,
and
right?
oxygen.
So if balance it, then it will be just this. That is known to us. That is minus 437, 439.7. Okay. Now, if you calculate what will be the this delta HF. This delta HF should be just like similar. Delta P minus delta R, correct? and
Yes.
delta P you can calculate from these values, bond energies, and delta R you can calculate from the heat of atomization. So, for that HR will be how we can calculate the values of HR? Just do it. Heat of atomization, carbon, oxygen, and hydrogen. So in two carbon, two hydrogen, and one oxygen. Okay, so it will be 2 times minus 71. Is it minus or plus? Minus 716.7 plus 4 times 218 plus 2 times 249.1. Just check it whether it is correct or not. 2 carbon, 2 oxygen, 4 hydrogen. So you can write it.
Yes.
Okay. So if you calculate, you will get minus 2803.6 kilojoule. Okay. This is the H reactant. And each product, if you calculate, then each product will be how many number of bonds are there. Just find it from here.
But I am getting it 1807.2.
Eh, no, just do it correctly. It will be around 1500. It is around 1000. So how it can be? Oh, I missed here a minus sign. It should be minus.
Okay, I am getting the same.
That is right. Okay, so each product you have to calculate now. Here, how many CH bonds are there? 3 CH bonds.
Yes.
One CO bond, one
OH bond.
CC bond, one OH
CO
bond,
single bond.
and one CO single bond. Okay, and all values are given. So just you can write it 3 into 3, 348, 732, 463, 351 plus X. What is X? X is resonance energy, because that is not provided to you. That energy is there due to this resonance.
Please
Okay.
repeat the concept.
Okay, just see, you can calculate the energy that will be same for these two structure, right? From this bond energies. If you
Yes.
calculate, that will be same. But additionally, due to this resonance, it will be stabilized. Extra stabilization will appear.
Yes.
That is called the resonance energy. Okay, that's why it is added here, X. And obviously, it will be negative because then only it will be stable. Okay,
Yes.
so this is the HP. So now you can calculate it easily now. So delta H formation, that is obviously HP minus HR, and that is given to you. That value we have already calculated. That was oh, not calculated, that was given, minus 439.7. So it is minus kilojoule. So HP is, oh, so what is this value? Calculate it. All are minus. Everything is minus. It is this.
It is 143. 3 into 143.
That is not 143. These are all one. Just
Yes,
take.
I am getting the same.
Okay, you are getting the same. So just put it here, and HR is. So what will be the X?
Minus 919.7. Sorry, point 1.
1 minute.
Sorry, plus 919.1.
Hmm. Plus
919.1.
kilojoule, right?
Yes,
Hmm. Now why it is plus? It should be minus, right?
yes.
But here we have already considered the minus sign. So we have considered the resonance energy as minus X. Already we have considered the minus. Okay,
Okay.
that's why. So resonance energy minus 191.1 kilojoule per mole. So see, it is a huge energy.
Yes,
Okay.
because it has equivalent resonance structure, which is highly
Hmm.
stable.
Highly stable. Right. So I'm thinking, should I start fugacity today or we should discuss few more questions? What do you suggest?
What time will consume for fugacity?
1 hour, 45 minutes to 1 hour.
Theory plus question.
Uh, because I will discuss mainly theory part, 1 or 2 questions. Mainly theory part I will discuss.
And for the remaining question,
For today's class, I have 3 questions to discuss more. I think that will be best. In next class, we will discuss fugacity from the beginning. Be-
if you have extra time, then no problem. If not, then remaining question.
No, today I don't have extra time. Next class I can discuss. Next class I have extra
Okay.
time, lots of extra time. Okay, so it was.
So extra problems we should done.
Mhm. And also I will take one extra class as well because I don't know why they don't mail anything, but generally they mail for extra 1 or 2 extra class. Because that Joule Thomson coefficient part and also that Gibbs Helmholtz energy part, gives that equation, that too I have to discuss.
How to solve this type of questions easily? Thermochemistry. I am unable to do. I am making mistakes so much.
You are making mistakes in the calculation part. Okay,
Yes.
so that you have to be your practice. Okay, I have a question set from this book. Um, so this question I can upload problem set. Okay, you can try.
Okay.
I think that will be good. That will be decent. and the note from of thermodynamics that I have already uploaded. Okay.
Okay. And the phase transition part, you
Phase transition note I have to find out. That part I will also
okay.
upload. Okay. So this is not from these questions I will discuss right now. That questions are not from this thermochemistry. That is in general question. So this can be a recap, you can say. This F is not formation. Okay. This is for fusion. What are given? You want to
Latent
try?
heat of ice.
Where is latent heat of ice?
It is not given.
No, no, that is not given. That is not needed even. Try it. It's a very good question. This is from which equation is needed for phase
Clapeyron.
transition? Yes. When you have seen the phase transition, you have to use the Clapeyron because from Clapeyron equation, applying the particular procedure, you can particular phase transition, whether it is solid to liquid or liquid to gas, you can derive the Clausius Clapeyron. Mhm. But in general, it is the Clapeyron equation. So what is the Clapeyron equation? You know that is
dH by dP. Sorry, dP by d.
del P del T or dP dt, let's say dP dt equals to
T
delta
delta.
H. Okay, now you do it. Okay, so this we are changing from, let's say, T1 to T2, and it is P1 to P2. Then you know, and we are changing from liquid to solid to liquid, melting.
Delta V is positive.
That delta V may be positive, may not be positive. That we'll look at later. So you can write it P2 minus P1, and this is the delta H, actually the delta H of fusion, correct? And that is independent, so you can take it out,
Yes.
and it will be delta H by delta V, and it is dt by T, so it will be ln T2 by P1. Okay, this is not the Clausius-Clapeyron equation, because in case of Clausius-Clapeyron equation, that is for solid to gas, or no, this is the Clausius-Clapeyron equation. For if it is solid to gas or liquid to gas, then it will be, instead of delta V, you have to put that the gas equation, right? That we have already discussed.
Yes.
So here everything is known, I think.
Yes.
What is P1?
1
That is
atm.
1 atm. And corresponding temperature, that is, 290,
0 degrees Celsius.
273 Kelvin. For
Yes.
P2, that we have to calculate
272 Kelvin.
72 Kelvin. Delta H of formation, that is given
Yes.
6.0095 kilojoule per mole. And that which is not given, that is the delta V that we have to calculate here. How we can calculate?
From PV equals to nRT.
Why? This is liquid and solid. How you can apply PV equal to energy? That is for gas. Do you get it?
Yes.
PV equal to energy for gas only. So we
I
can
think
write
one derivation there was considered this equation for solid also.
in which derivation? Never. But in that case, if you consider the del V for gas, solid to gas, then it is like this. And you ignore the solid part and you can write Vg and you can write is nRT by P.
Yes. Yes.
That is a different thing. You are ignoring the volume of solid compared to volume of gas. You are not writing Vs as a nRT by P. That is a blunder. You can't write it.
Okay.
So density, So, and for solid or ice, for a particular mass will not change. The density will change. That's why the volume change, right? Because
Yes.
one gram of ice will be converted to 1 gram of water. Essentially, that will not be changed. So you can write it m by dl minus m by ds. That you have to calculate now. Okay. So
Okay.
everything is for 1 mole. You are calculating for 1 mole. So mass m will be 18 gram for 1 mole, obviously. So mass and these data are given to you. D this is given to you. 18 gram per mole. Let me write it. So you can write m into, then it will be ds minus dl divided by ds times dl. Or don't making it, just do it in calculator. So it will be 18 gram per mole, and it will be, just calculate it, 1 by 0.9978 0.9170. It will be, unit will be here it is gram per cc, so it will be cc per gram because it is 1 bar. Cc is centimeter cube. Just do it. What will be the answer?
Minus 1.589.
This is centimeter cube mole inverse. Okay, del v we know now. So P2, just that will be P1 plus, from here you can write P1 plus delta HF, delta HF by delta V ln T2 by T1. T2 by T1, that is 272 by 273. And what is delta H by F? Delta HF. What is delta HF? Delta HF means this is, you are considering solid to liquid. So when it is solid to liquid, heat will be emitted or absorbed. You have to give heat, right?
Yes, heat will absorb.
So it is positive, and that value is 6.0095, and this is minus 1.589. Just calculate it. And what will be the unit? Unit will be uh, delta HF has the unit of kilojoule per mole, and this is centimeter cube per mole. So unit will be kilojoule per cc. Let's calculate it.
1.1387.
Kilojoule.
Total answer. Total answer.
Kilojoule per centimeter cube, right?
Yes.
Now kilojoule per centimeter cube means 10 to the power 3 joule by 10 to the power 3,
Centimeter cube.
sorry, 1 meter cube, not 10 to the power 3, 1 meter cube. Okay. And joule is Newton per
Meter square.
meter square, and it is 10 to the power minus 6, I think, meter cube. Am I correct? 1 centimeter equals to 10 to the power minus
Yes. 2 meter.
2 meter. So 1 centimeter cube
10 to
will
the power
be
minus 6 meter cube.
minus 6 meter cube. So it will be 10 to the power minus 3 Newton per Newton. What is joule?
Newton per meter. Newton into meter.
Newton meter, right?
Yes.
Now it's correct. So it is 10 to the power minus 3 Newton per meter. Let's see whether
Meter square.
meter square.
Joule.
Newton per meter square is not joule.
Sorry,
Pascal.
Pascal.
Pascal, right?
Yes.
Unit of pressure. So it can be written as then 10 to the power minus 3 Pascal.
I tell it 1.01387.
1 point
01387.
this.
Yes, and total after adding P1. P1 is 1 ATM after adding it.
No, you can't add it. You can't add it. This is in
Okay,
ATM.
sorry. Then it's 0.
0 point.
0.01387.
Hmm. Whether you have calculated this 10 to the power minus 3 part or not.
No.
So 10 to the power minus 3 part will also be there then. Okay.
Okay.
Just check it whether any mistake is, because
Okay, everything is correct.
correct na? So, okay. So Pascal and ATM. Now we have to relate Pascal and ATM. How you can relate Pascal and ATM? Pascal is Newton per meter square. How you can relate?
By the R value.
By the R value. That is the best thing. So you know R is 0.082
Liter atmosphere.
liter atmosphere. Mole inverse, Kelvin inverse is there. I'm not bothering with that. And also R is
8.314 joule.
8.314 joule. Joule, joule. Yes. So now you can compare. Then you can write it from here. So 0.082 liter ATM is equals to 8.314 joule, correct?
Yes.
So 1 liter ATM is 8.314 by 0.082 joule. Calculate it.
101.4.
1 point.
101.4.
Say it again.
101.4.
Okay. This is, and now 1 liter is decimeter cube. So it is 10 to the power 3 meter cube ATM,
Yes.
and joule is Newton meter. So
Yes.
1 ATM is, correct? Do it. This is 10 to the
Yes.
power 3.
0.1014.
0.1014 Newton per meter square. And we have this. So we have 0.1387 into 10 to the power minus 3 Newton per meter square. So that will be obviously 1 divided by, oh, sorry, this is 1 ATM. So it will be divided by 0.1014 ATM, correct? Hmm. Calculate it.
Can you please show upward? It is 0.01387.
Okay, 1 0 extra, right? So what will be the answer?
0.13.
1 minute, 1 minute. This is correct, right? Okay, 0 point.
0.1368 into 10 to the power minus 3.
No, no, no. Anything is wrong. इतना कम कैसे हो सकता है? Anything is wrong. In general, 1 ATM is around 10 to the power 5 Pascal, okay? If I'm not wrong, 1 bar is 10 to the power 5 Pascal, I remember. Oh, it is 10 to the power minus 3, correct?
Yes.
1 meter, yes, so it is minus 3. So do it to it. That's right. So it will be into 1000.
The 10 to the power minus 3 part is not there.
Minus 3 is in denominator. So it will be 10 to the power 3.
No, no, in the answer it is 0.1368. Last answer.
No, no, that is wrong eventually, but here 10 to the power 5 will be there because it is 10 to the power minus 3.
Okay.
So it is 1.01 into 10 to the power 5. It's getting worse. Anything is wrong. This is correct. This part is correct. Okay. This is correct. I know. This value is matching.
My alien calculation is also correct.
Alien calculation is correct, but this part
Yes, this also.
is also correct.
Please wait a minute. I am calculating again.
Hmm. This is kilojoule. So here is a 10 to the power. They have remind it is kilojoule. So let me write it like this.
Thirteen point 8786.
It's 6 total,
Yes.
considering ln,
Yes.
and it is joule in centimeter cube, right?
Yes.
Now you have to convert it into the meter.
Yes.
So in meter, it will be 1 meter equals to 10 centimeter. So 1 centimeter is eventually 10 to the power minus 1 meter. Ah, minus 1, not minus 2 meter.
Yes.
Correct. So 1 centimeter cube 10 to the power 6. So divided, it should be divided by 10 to the power 6. Or I am doing wrong. I don't know. Joule is obviously Newton meter. It is 10 to if it is 10 to the power minus 6. Let me do it. 1 minute.
If it's joule per meter cube, then 10 to the power minus 6 will be multiplied.
Hmm. Okay. One meter is 10 to the power. This is correct, right? One. This is correct. Nothing is wrong. You can write it as joule per centimeter cube. So it is eventually. Oh, hmm. Okay, what are you saying? What was your answer?
This only.
This only, so it is eventually 1.38 into 10 to the power minus 5.
Yes.
Okay, then it is Newton meter square, and 1.10 into 10 to the power 5 is 1 atm. So it is 1.38 into the power minus 5. I don't know what is happening. It's very small value. I don't know, some date mistake is there. You see, just one power mistake is there, I think. Okay, leave it. I will check it, okay? Whether there is any misinformation or not.
Okay.
Okay. The procedure is same, procedure correct, but probably there is some thing, error with these units. Okay, that I will check. Okay, so today you can stop here. I will solve it in next class and the fugacity part also.
Okay.
Let me stop sharing because today I have class 6:15. Okay, thank you for joining. We'll meet again in next week. Okay, from
Please find the notes for the phase transition.
yes, I will send the note of phase transition.
Okay, thank you.
Okay, thanks for joining.